Hi and welcome everyone to this episode of Breakpoint. The topic for today is packing a punch with policy as code. Software ecosystems throughout the world are getting more complicated with new technology creeping in all the time. Often, we start with many tightly coupled practices, which later make it difficult to scale security for our fast-growing tech stacks and organization. To discuss this not so simple topic, we have with us today Abhay Bhargav, who is the founder of V45 and AppSec Engineer. He's also the Chief Research Officer at AppSec Engineer and is involved in training for AppSec, Kubernetes security, as well as scaling AppSec with cloud native security and DevSecOps for organizations. Hi, I'm Neelu, a technical security enthusiast and your host. I welcome you to the Breakpoint Security Podcast. In this podcast, we'll explore the depths of defensive security. We learn the methods and techniques that the smart security teams are using to solve practical security challenges today and innovate their way into the future. Welcome to Breakpoint, Abhay.
Thank you so much for having me, Neelu. Appreciate it and look forward to this discussion on policy as code.
So, Abhay, maybe if you could briefly tell us, for our listeners who may not know policy as code as such, if you could briefly simplify that for them as what is policy as code?
So, policy as code is basically, I think the simplest way to explain policy as code is all the controls you thought you wanted, right? So today, let's take a simple example. I'll use an example because I think examples everybody will understand and appreciate. Now, let's say I am running an organization. I have a bunch of applications that are deployed. Now, let's say somebody is a developer who has access to things, right? So let's say the developer has access to an environment. They're authenticated, they're authorized, they have all of that stuff. They have those privileges, but they end up deploying an application with root username and password to production. Let's say that happens. Now, the idea behind policy as code, the problem with that kind of a scenario typically is that you always need to have, we are used to doing post-mortem analysis, right? We're used to saying that we scan something with a vulnerability scanner, like whatever, Nessus or something, and then we find, hey, this has Tomcat on the web server. But what if we could implement a policy that would not even allow default password, applications to be launched on that particular web server, or applications with a poor password to even get launched in a particular given production environment? What if we could implement a policy that mandated and essentially forced that developer to use a strong credential before they even deploy? And what if that policy was not just written as a nice, beautiful statement on a docx or a PDF? What if that was enforced through some kind of a tool which you could codify, which you could essentially manipulate, which you could essentially control in a way that you can scale it out? So that's basically policy as code. The idea behind policy as code is that you should be able to take any type of security authorization policy, any kind of security policy, and convert that into code. The idea behind converting that into code is because you can deploy that into any environment or any target environment, and that target environment automatically starts enforcing that policy for you from that point in time. So the idea is that it's automated and it is as code, because as code gets more traction, right? You can have developers write it, you can check it into a Git repository, you can test it, you can do all of that stuff. So as code becomes a very important part of the policy as code part of it. So that's really what policy as code is about.
Thanks. I think that's very well simplified and put for the listeners. But when we think about policy and as code, right, we are now talking about, particularly at an org level, we are talking about a lot of things.
Yes.
And the first thing that comes to mind is there are various aspects to the policy itself, right? A security
Yes.
policy will have various aspects, and there are
Yes.
multiple considerations when it comes to that. For example, there may be different data points, data sets that you have to consider,
Yes.
whether it is business data, sensitive data, how you handle that. Plus, there'll be network configurations, right? There'll be compliance requirements for that
Yes.
matter. There'll be regulatory requirements that will come in. And on top of that, you will also have, as a security team, to think about what about the access control? Now, who gets access to what?
Yes.
And in any medium to large size organization, that can be quite overwhelming. So
Yes.
in your opinion and in your experience, particularly, where should we start and what should we prioritize when it comes to even thinking of policy as code for our organizations?
Yeah, no, that's a very valid question, and I think that is a question that needs a lot of practical thought. So, if you think about where I would, so let me talk about it from a personal perspective as well as what I've seen work with our customers, clients, and people I speak to, in the broader industry. So, wherever I feel that the first place you should start policy as code is wherever there are APIs for it, right? See, the problem is that today you have a lot of legacy systems, you have a lot of legacy environments, things like that. You may not be able to do policy as code for them to begin with. You may be able to, over time, mature your policy as code implementation into all of those things. But you need to have APIs that support this sort of an implementation first. And those systems should be configurable entirely through the API. Right, that's very important. So, which is why if you see traditionally, I would say that, when traditional is a very big word in IT because our traditional is about 6 months old. I'm saying if you look at the last couple of years in policy as code, I would say the most amount of policy as code implementations have gone into Kubernetes, largely. The reason for that being Kubernetes is entirely API. So, which is why people they've built products around it, they've built open source products around it, commercial products around it. And that's why the concept of policy as code has really gotten a lot of traction because of Kubernetes. But if you look at it otherwise, you've generally not seen that without Kubernetes, for instance, it would have been a much slower ride for policy as code. So I would say wherever the ideal starting point should be where API configuration is entirely possible through the API, right? Wherever you have API-driven systems where you can configure this, it could be on the cloud. So for instance, Azure has a pretty solid policy engine. AWS has a pretty solid policy engine. Kubernetes has a bunch of tools that you can use for policy as code. Again, these are entirely configurable through API. So these systems, I would say, start with them because you don't want to start saying, hey, you know what, this application was built in the 1980s. Let's start applying policy as code to this super legacy application that we are deploying from the 1980s onwards. It's not going to work simply because that application probably is deployed in a legacy and infrastructure. It probably has several considerations that does not even touch, an API gateway or any other API endpoint. So there's a good chance that you'll not be able to do that. So don't try and take on such projects to begin with. You can probably, as your stack matures and as your policy as code matures, as the other parts of your infrastructure mature, that's when you can start taking up more complicated, more challenging projects.
Yeah, and I think it's also a quick win for security teams when it comes to that. You can show the effectiveness very quickly on all of this, and of course, get the benefit of that very quickly.
Exactly.
So that might also be a simpler case where you can quickly implement. It'll be like your MVP in a way.
Yeah, no, it is. It is. It does become the starting point. That's why I said, because Kubernetes came, everybody started thinking about policy because they were like, how do I manage this beast? Kubernetes is a multi-headed hydra. So it's like everyone was like, oh my God, if I don't put some automation that enforces, non-root containers, that enforces a certain type of access control parameter, that enforces certain types of containers being launched or certain types of pod labeling, things like that, it'll just not scale. I cannot do this manually because you have random people deploying containers all the time. So it gets more complicated. So that's why I think Kubernetes has gone a long way in helping the cause of policy as code.
Yeah.
Yeah.
So while we're talking about, simplifying the implementation, starting with APIs at the first stage, can you give us an example like of any challenging or complex policy that you had to translate into code so that the listeners will better understand, what does that mean? What does that involve? What are the stages to it? And how do you overcome these complex policies, which might be actually interdependent on various systems and components?
Sure. So one of the things that my company does at V45, we do a lot of security automation implementation. So we do a lot of DevSecOps work, security automation work. So probably one of the most complicated ones that has been a resounding success. Of course, we've had a couple of ones where there were some unrealistic expectations also from the customer, but in most cases, people understand what they're getting into. So with policy as code, one of the biggest successes that we've had, and the most complex one as well. So your biggest successes tend to be one of those which have been the hardest fought, right?
Yeah.
One of those biggest successes for us. So in this case, this was an e-commerce company. They had a bunch of APIs. Obviously, everybody loves microservices today. So they had jumped on the microservices bandwagon like nobody else, that started building a ton of microservices and quickly realized that had grown out of control. They were using Kubernetes, they were using these microservices, they had an API gateway, and they started seeing all kinds of authorization bugs. Access control bugs were just literally everywhere. Simply because obviously when you have that many microservices, one of the big issues is that developers don't tend to do a consistent job of handling access control on each API. Imagine that I have 100 different API teams. One team is a Golang team, one team is a JavaScript team, one team is a Java team, and each of them have implemented authentication access control in their own way. So it basically became an unmitigated disaster for them very quickly. So one of the things that we first did was we told them that, look, the biggest problem that you have is that you have this proliferation of services and you don't have any control over these services. There's just no control over these services. But the thing with them is they had relatively tight access control parameters. So what we did was we implemented at the API gateway itself, we implemented Open Policy Agent for them. And we also implemented an integration with another dynamic access control, again, policy as code system called Casbin. So we hooked these two up together. So every single time a request came in to the API gateway, the API gateway would not only verify things like the JWT, the token, the claims, etc. It would also dynamically check whether the user was authorized to perform that action against that object, which means that from that point onwards, the API developer did not have to think about access control at all. The API developer could be completely oblivious to access control. All the access control was entirely dynamically managed through the API gateway because of this solution. And that was, I would say, a pretty big win, because they immediately saw I have 5,000 different access control bugs to almost 10 or 5 or something like that. So they started to see a huge drop in the kind of bugs that they were seeing, especially related to access control. The good thing with them was they were at least security aware on the other ends. We were not seeing SQL injection and command injections all over the place. At least that was sorted. But these kind of issues can have massive downstream effects, because access control bugs are one of those bugs where it starts small, but the crack kind of widens as you go along, and it widens very slowly. So people think that it's not a big deal, but as it widens and widens and widens, some point in time, somebody is going to get access to some service that is serving up a whole bunch of crazy at some point in time, and that becomes an issue. So this was,
with issues, the security issues will also scale when systems scale, because that's the attack surface. But do you get questions around, and I was just curious because we have gotten those kind of questions where you are doing an implementation on a complex bit, right? And how does it impact the performance at the end of the day? So do you get those questions?
Yes, we do get those questions. See, and those questions are legitimate, but also it's the good thing today is that you have tech that reduces performance implications by quite a bit. See, for instance, Open Policy Agent is one of those frameworks that we use quite a bit of, and it's one of the most popular policy as code frameworks out there,
Yeah.
right? As we speak. So the thing with Open Policy Agent, just as an example, I'm not, I mean, they're an open source project, so I'm not definitely not
Not the ambassador for.
So it's not that I'm monetizing my love for Open Policy Agent. But the point with Open Policy Agent that I like is that they are, first of all, they're a completely separate framework, they're a separate language, they're written in Go, which is quite lightweight. It's also quite performant. It's performant on the cloud, can be scaled quite easily on the cloud. I think it's really, most of these things are really about, even from a performance standpoint, unless you are dealing with, let's say, a system that has, even with those systems, even with the e-commerce system that we did, they had massive performance. I mean, they had massive performance needs. And even with that, we didn't see a loss of any sort, simply because most of these systems today are quite fault tolerant. They are single purpose. So we didn't see that kind of a performance drop. Of course, you can architect your way into any kind of a hellhole. So that's not saying much. But if you do design too many checks, or let's say you have 3 different systems that are doing 3 different things and then talking to one different point of failure, yes, of course, you can still do a lot of stupid things. But if you even marginally know what you're doing, performance should not be so much of an issue.
Yeah, and that you were talking about this being in Golang, and this is, I think I'm distracting a little bit from the mainstream here. I do like the fact that many of the security products are now coming up with their own tech stack being in Golang. So this is something that I've seen it to be really performant, and I think it's also being used in many banking kind of systems and all of that. So I think it would be good for the security products in future to choose such tech stacks themselves.
I really hope that Java and C gets replaced by Golang, Go, and of course, they're happening. I hope that happens more and more because, Java in a lot of places, while it's stable, it's still very painful to deal with. Of course, Go has its own set of issues, but I really would like to see that, and I think. Especially when you're on a cloud native sort of journey, having a Go security or a team that is Go centric is going to be very important. And I've seen that. So if you have a company that is doing a large scale Kubernetes implementation, a large scale, anything to do with containers, I tend to see at least a couple of Go folks on the team because cloud native is kind of Go's territory.
Yeah. So, okay, coming back from the security products tech stack to the tech stacks in the organization, you were already talking about the API scenario, right? And then you're talking about different tech stacks being used by different teams.
Yes.
So in terms of the implementation for Open Policy Agent, or for that matter, any kind of policy as code. Yeah, can you hear me?
Yes, I can. It was fine.
Yeah. Oh, I heard something from your side. Okay, I'll start again. So coming back to the tech stacks across the organization, for any medium to large size organization today, we deal with a wide variety of tech stacks, right? So different APIs, different teams might be using different tech stacks. And now in this context, when you talk about policy as code, as a concept itself, it needs to unify the policies across all of these, not just the teams, but across the organization many times. So how do you ensure the implementation itself is consistent, although the tech stacks vary so widely across the organization?
Okay, this is also a very important concern. And I think this concern is still kind of a valid concern. When I say valid concern, I mean, this is a concern that I think it still remains a concern to a certain extent. And I'll explain why. Now, when let's say you have an organization where you have Java, you have .NET, you have, whatever, Ruby on Rails, you have Go, you have whatever. You have all of these different APIs, you have different teams. So when you're doing policy as code, you either have to do it in a completely different language, which is completely different from this, right? Because if you try and say that, hey, let's use this Java-based framework, all the other folks are going to be like, hey, I can't do this. This is not really easy for me to do. It's not ideal. We have to relearn the whole thing. Java sucks, etc., etc., etc. Right? So you're going to see pushback there. So it either has to be in a completely different language, or if you are doing it within the concept or the framework of that language, it has to be a system that supports SDKs in that language. Now, the second part is usually much harder to achieve, because most of these systems don't do that, right? And I feel that that's a good thing. I mean, I know I'm making a relatively opinionated statement here, but I stick by it. And I'll tell you why I stick by it. Now, if you look at policy as code, especially in good policy as code, it's either, especially for Kubernetes or cloud native or cloud, it's either in the cloud provider's language itself or in their own template, or it's in YAML, right? Which is in the case of Kubernetes. Kubernetes, everything is YAML. This is also YAML. So, more YAML. I know people hate YAML, but that's just, Kubernetes works. You have to deal with it. So I'm okay with that. Or with Open Policy Agent also, I'm okay, because they have their own language. I think the good that they did was they were not like, hey, let's build this as a Go library. They have done that as well, but it's a separate language from a typical language, right? So from Java or Python, or it's a completely separate language. If I told a random team that, hey, this is a Python library, a drop in that you can just build this one, policy as code framework, as soon as I say that, I would hear pushback from them saying Python is super slow, everything, I have to worry about this, I have to worry about that, there is no exception handling, there are 5,000 issues people come up with. So the way I see it is that the fact that these things have to be authored in different languages, which are more environment centric than stack centric, I think is better. Excuse me. So yeah, so like I said, I think it's better that these are more environment centric than stack centric. The stack actually should not matter. The idea is to get to a point where the API doesn't know that policy as code exists. Policy as code has to happen before the request even hits that API. That's where the real win is. So the API should be operating in a completely clueless, ignorant way. And policy as code has to do everything around it, which is going to be purpose-built. So for instance, to just give you a perspective, let's say a request comes in from the user, all of your authentication, access control, input validation, at least to a large extent, should be done at the API gateway. Once the request hits the application, then the application should have instrumentation of some sort. Either it could be some eBPF stuff, it could be some mandatory access control at the kernel level that should start enforcing it there. None of this the application even knows exists. The application doesn't care. The application just does this job, which is business logic. I'm here to serve the business. I'm going to give you the business logic. That's about it. That should be the overarching goal, I would say, of any policy as code implementation.
Yeah, and I think so. The point, if I understand correctly, that you're driving is the fact that in many cases it is language agnostic or tech stack agnostic itself empowers it to detach from the application and do its thing right, even before, in many cases, before touching the API itself.
Yes. See, the reason, just to give you an analogy from a cross-cutting concern, today, if you look at it, if you look at infrastructure as code, which is the most popular infrastructure as code tool today? I mean, it's Terraform. Terraform.
Yeah.
Exactly, right? Why Terraform? There were specific options that each and every cloud provider provided. Amazon provided cloud formation. Azure provided ARM templates. They provided a whole bunch of mishmash. Then you had GCP who provided nothing at all and just expected us to point and click. And you had Kubernetes also. You had another cloud, you had Alibaba, you had Okta, you had all of this stuff. The only way it could have ever worked was if there was a completely different way of spinning up these resources that were declarative and that made sense intuitively for a developer. And that's why Terraform has won that race. I would say the same thing applies here.
Yeah. And I think in many cases, these are also not very difficult to learn, like not like the other tech stacks that we have. And
Declarative, right? So as soon as they're declarative, difficult to learn is a very subjective statement, but I would say there is a lower barrier of entry, I would say, to the learning process for this versus imperative, which is your typical programming language. So that is something, this is more purpose built, right? You're not learning OPA to write a web application. You're not learning Rego, which is OPA's language, to write a web application. You're just learning it to literally implement this one thing, which is policy as code. So that's really where the benefit lies.
So moving on from the tech stacks, there are some other practical challenges that you would see even in smaller or mid-sized organizations. And it may become important to address that depending on where in your security journey you are. So for example, the issue that I wanted to, check your opinion on was, what do you do when the organization itself is scaling? So for example, you have the initial set of rules it's written, you have the initial set of policies there, but now your organization is scaling in the sense the number of APIs are growing very, very fast. And even from an infra standpoint, your cloud environments, for example, are growing, or for example, you're going multi-cloud. So these are things which are not very straightforward. What are the specific things that you would prioritize or take care of in such a scenario?
Right. The answer again in this case gets a little complicated simply because we are going into enterprise culture territory here. So as soon as you go into enterprise culture territory, things start to break down. It's never a technical problem. It's always a convincing X or Y or Z problem. So that becomes the issue. So, but there are a few things that I think every company should do who is trying to embark on not just this journey, but any journey into better security, right? The first thing I would say is, first of all, set the right expectations. So setting the right expectations, I mean creating awareness with the teams that are concerned about this solution even existing, right? Most of the time people, it's not that usually within companies, I've seen terrible messaging simply because people just don't explain what this is. They just say that, we are implementing this, and most people feel left out of that decision. They don't understand what on earth that is. What is OPA? What does Rego mean? What does policy as code mean? Most people don't get it. It's not intuitive to everybody that, this is awesome. This is going to reduce my job. So marketing is always important for anything. And within a company, within a team, within any kind of small, medium, large, it's important to market things and market
especially
it
for security.
Exactly. So it's very silly to expect that, while I'm going to make this top-down decision, everybody better follow it. That kind of approach doesn't work. So I would say awareness training on this stuff makes a big difference. The other thing that I think makes a big difference is threat modeling, weirdly speaking, which has nothing to do with this. Most people, so if you have something like this, if you've started down this journey and you do a decent job of threat modeling, a lot of the controls can be fixed with policy as code. The problem is, if you don't do a threat model, you would start to realize that everything is now offloaded to the application. So threat modeling, I would say, is one of those fundamental things that you should do to reduce the burden on your application and build in more impetus on policy as code. So for instance, if you threat model an application and realize that access control is your big issue, and somebody says that, you know what, this can be offloaded to this particular component that is meant to do access control, then you can start talking about the fact that, hey, yeah, oh, this is there, we can do it, we can definitely implement it this way, and excuse me, get that implementation rolling as soon as possible. So that is the benefit of threat model. The problem is if you are in this predefined control mindset, then it will not fly. So I would say these two things are going to be very important. Of course, there are lots of other things, but I think these two really critical things are very important for this initiative and many other security initiatives to succeed.
Yeah, I think I totally see where you're coming from. I think having done it for some of the organizations where, in fact, at the level of threat modeling, you can draw a parallel in terms of various different APIs or applications showing similar threats, and you can have an org level, for example, product policy or security policy around just for products, or even network, because threat modeling is not limited to the code lines of code which are there, right? Or a specific issue, or for example, cores. I mean, no offense to all of these, because all of these are bringing in a very specific perspective, wherein threat modeling will bring in a lot of width in terms of your idea and visibility into what threats you have, and then having that centralized sort of a policy will then implement that across.
Exactly. So if you have done an effective threat model and you're already on this journey, so you can start offloading things to this, which makes your life easier in the long run.
Yeah. And you can also quantify a lot of that in terms of fixes, because now you have policies for that which already prevent many of these threats.
Exactly. That's a very valid point.
But what about the, for example, if you're going multi-cloud, are there any specific things to keep in mind in terms of policy, or something that you should have formulated already in terms of policy as code when you're going multi-cloud?
So with multi-cloud, it tends to get a little diversified. Okay, so because each cloud provider comes with their own. So when you look at multi-cloud, it really depends on the how the cloud environments are laid out, right? So there is, in multi-cloud, the first thing you have to ideally do is first figure out the policy at the cloud control plane level itself. So for instance, what you should do, let's say you're using Amazon and Azure, right? Let's say you're using Amazon to host to run containers, and Azure to run VMs and databases, whatever. I'm just giving you a off the top of my head example. It's not, it's just contrived. Now, the policies that you can automatically set up certain policies in Amazon using service control policies or something that says, hey, you know what? You cannot launch containers outside this region. You can't launch containers maybe with this kind of a configuration. People who don't accounts that don't have this kind of a set of access parameters cannot launch this particular container. You cannot run any other service other than the ECS or Fargate service in AWS. You can create those SCPs and load that into your account if you're using AWS Authorization. You can do the same thing in Azure. So that is kind of like the baseline pre-prep baseline policy that you can use to build additional things on top of it. So when you're going multi-cloud, it's very important to understand the policy engines within each cloud. Because unless you're using, of course, if you're using like commercial tools and stuff like that, they kind of do it for you. I would think at least some of the good ones would probably do it. But if they don't, there's a good chance that you will have to do it yourself. So it's very important to understand these policy frameworks for each of these clouds and then implement it accordingly. So that becomes a little bit of a challenge with multi-cloud. So that is where I would start. And from that point on, I would use the similar framework that I would use for everything else in the stack. But that bedrock part of it has to be very clearly laid out. Excuse me.
Yeah. Thanks a lot for that. I was also thinking about policy as code, and when we are defining policy as code, it could be at any level, like we were talking about, and it could also be at the level of organization. It caters to various components in the organization. But the favorite, I think that's my favorite and your favorite as well, is how does it cater to the CI/CD pipeline, right? What is the difference that it can make if you do it well in the usual DevSecOps, in the CI/CD pipeline itself, for the day-to-day activities of the development teams and for security teams also, for that matter?
Okay, so there are two angles to this, right? So there's the first one, which is policy as code for CI tools itself, right? So, or policies for CI tools. And then there is policies through CI tools.
Okay.
Now, there's policies for and policies through. So let me explain the through part first, and then I'll explain the or two part first. Okay, so the next one. So the through part is really, see, policy as code by nature, when you can define something as code, it is testable by nature, right? You can run unit tests on it, you can run integration tests on it. And that is the idea behind policy as code, right? So you should be able to commit it to a Git repository and run CI/CD jobs to test that policy as code. So let's say you have an OPA, a Rego file which has a whole bunch of validations and access controls, etc. You can unit test it like any other piece of code you have, and then arrive at whether you should pass it or fail it, or whether it should go to prod or not go to prod, etc., etc. So that is the through part of it, right? So that is very important to do as well, and that is it's still not done well in most cases, but it should be done. The second part of it is CI/CD policy as code itself, right? Now, this is a little bit more underformed or undercooked, because most of your CI/CD tools still don't support policy as code from that perspective. They do support it to a certain extent, but they don't support a very mature view of policy as code. You can do a few things. You can still, you will have to again implement OPA or some other type of policy engine outside of the CI/CD system, and then probably do it that way. But with CI/CD systems, you would have to use the system itself to kind of define whether it should move ahead or not. So, which is why if you want granular policy controls of your CI/CD system, the best thing to do is not use a CI/CD system. I know it sounds kind of stupid, but let me explain what I'm saying. So if you want a decision tree like CI/CD system. So for instance, let me give you an example of what I'm talking about. So let's say I commit some code to, let's say I'm a Python developer, some code to my repository, right? Now, let's say it's a multi-repo or a mono-repo kind of a project where I have a lot of other projects as well. So let's say in that particular pull request, if there is a Python file, only then scan it. If there is a change to requirements.txt, which is my supply chain, only then scan it. If the scan results are this, then do this. If the scan results are that, then do that. Push it to Jira, push it to Slack, push it to all those things. So that is a state machine, right? What you're looking at is a state machine. You're essentially drawing up a flow chart and saying that do this. If this is not the case, you do a conditional and do that. If this is not the case, do a conditional and do this. Otherwise, do this in a loop, do this over a long period, whatever it is. Now, most CI/CD systems, while they can handle some of it, they can't handle more complex flows than this. So that is why what I've seen some of my customers do, some more advanced people who want to do these kind of flows as CI/CD, they tend to use things like logic machines or state machines in the cloud to do some of this stuff. Or you can use, dicyclic graphs to be able to achieve this on a, there are systems that are like, there's Prefect and there's Apache. There's one project by Apache. I'm not able to recall. I think it's Apache Arrows. No, I'm not Apache. No, I'm sorry, I'm not able to recall. There's one called Prefect that again allows you to define these very complex workflows, and you can do it from there. But yeah, CI/CD policies still need a lot of work, because if you look at the big systems in CI/CD today, you have Jenkins, you have GitHub Actions, you have GitLab. and maybe circle CI to a certain extent. Now, all these four systems still give you, it's not really policy that you can configure as code. You'll have to do it through their API. You can do it through Terraform, maybe to a certain extent, but again, it's not that malleable, right? There are lots of things that can go into GitHub configurations or actions configurations. There are a bunch of things. So I would say that this is an area that still needs to get a lot of attention. I don't see that being there as of yet.
Thanks, Abhay, for detailing that for us, particularly with respect to CI/CD, because many times we do talk about CI/CD and stress on a lot of different kind of automation, while there is a lot of stuff around policy as code, which is available. And to what depth and to how far you can actually apply it to CI/CD is what I wanted to know.
CI/CD weirdly, which is so automation oriented, is weirdly anti-automation in some cases. So it's a little bit of it still relies a lot on point and click style stuff that you need to do, or logging into a console that you need to do. So it's still not as friendly from even though it's a hardcore developer tool. CI/CD systems are still not super friendly for developers, which is an irony in itself.
Okay, on that note, we'll end the show here today. Thanks a lot for joining us and having this really lovely discussion around policy as code. I was actually not expecting this to be that interesting as it was today. So thanks a lot, Abhay, for having this interesting conversation with us.
Thanks for having me.
Okay, thanks everyone for joining us today. We'll see you in the next episode. Bye-bye. Hey folks, that's all we had for today. I hope you enjoyed this one. Visit the podcast page for more such interesting episodes. You will find the speaker suggestions and other details in the show notes below. If you're interested in a security challenge of your own or would like to hear from a specific speaker or team, let me know in the comments below. Lastly, if you liked the episode, please go ahead, give it a thumbs up, subscribe, and share with others in the community. It always means a lot when you do that. We'll see you in the next episode. Until then, Breakpoint signing off.